So hi guys, to the developers meeting on July 14th. Yeah, sorry. This will be a short session. I just want to demo the latest steps towards ADSB integration. Yeah, we talk along the line, so I start doing it now. So what you see first is here, that ADSB is connected via an RTL SDR dongle and a 1090 filtered antenna. The size of the antenna is about 60 centimeters or so. This antenna is, I'm now indoors, so this antenna is next to my window, and I can only capture the northern side of the area here, because above me is a roof and there's no signal coming through. Okay, so what you see is here are squawks coming in, and I only pick up the ones that really resolve into latitude and longitude. All others are ignored. Yeah, so the camera is working. Where is it? Here it is. Camera is feeding frames. Background subtractor is doing its job, and too many windows. Yeah, I can start the viewer, which reads from the same shared MEMS. And what you here see is the live frame. You see my hand. What you also see is a little tiny dot in the center. This is actually my test object. It's a little needle on a string, and it's hard to see because it's a little needle tip. So it resolves, I think, in 4 pixels. I can now activate the background layer, and you see it is responding in the background subtractor. Let's move it a little bit more. So this little tiny thing is well captured. And even major distortions are now going back to the background. Right. So I'll just turn this off for demonstration and turn on the ADSB. This camera view is 160 degrees. So the outer radius circle that you see, the outer circle that you see in dark red, I just make it bigger, I think it's more easy to see. The outer circle is 160 degrees. Because with this alignment of the optics and the camera, we cannot come closer in order to make it sharp. So there's a little cut off from the 180. So we use less 10 degrees to the horizon less, which in most cases makes no sense anyways, because there's so much atmosphere in the lower levels that the first 10 degrees don't resolve anything useful anyways. So the next circle is the 90 degrees circle, a 90 degrees circle, but it's the 45 degrees when you stand right up and look to the sky. It's the 45 degrees angle. So, and what you see is now there are airplanes coming in. Okay. Oh, it's working. Yeah, okay. So there are 2 planes now resolving with latitude and longitude, and both are marked here now as a quick mark. This is not the end viewer, it's just a working environment now. So it's just to pinpoint where the object is and how it moves. And this object should update if their latitude and longitude are updating. They also shall update here under their position. Yeah, which this is actually because now not doing. Thank you very much. Anyhow, what you see are parameters like the flight ID, the altitude that it is moving at the moment, the ground speed in knots, and the heading in degrees. So this means it goes south. The distance is calculated via geodetic curve of the Earth, and as a spherical model. And this is resolves now to 73 kilometers distance. And this does not update. Why? Okay. Oh, there's a new one coming in.
It would be interesting to see an image of the sky and then comparing basically the coordinates.
Yeah.
The
Now
detections.
I have a problem. The view is not updating anymore because the live stream from the camera kicked out. I need to restart the camera. So this is an issue I'm still have to resolve. It's the kind of a buffer overflow. So when you start setting a target FPS, then I have an algorithm that tries to keep this in sync so that we have, let's say, an FPS of 6, so that the requests to the camera come really in this time frame. But the result is different. So what you see here, this is the real FPS from process time and so on. And you see every grab is a little bit different. It should all be 6.0. And the delay on any loop is calculated ahead for the next to occur, which means I'm always running behind. And I have to adjust this. This is, I know how to do it, but I haven't done it yet. So this means that we have at certain points, like now, super. This is really a demonstration situation. I love it. So what you see here is we have sometimes 3.9 and sometimes even above 8. So this means if there's so many requests per second that the camera can't handle, and I know that the camera begins stalling after 7 frames per second, that's why I always keep it at 6 frames per second to be on the safe side. But the result in reality is that the FPS is higher, so there's more requests than the camera can handle, which results in a kind of a buffer overflow. The stupid thing is I can't capture this. The camera doesn't tell me when it's buffer overflow, or if there are too many, if the queue is too long or whatever. Any information about the queue is not in the SDK. I can't do anything about it. So I have to make the code more restrict in the sync of requesting the data. That's it. So in this case now it's not that far. So sometimes it hangs.
We need to probably think about what to do with the camera if we're using C++, because now with eCal we can have basically an SDK or an interface with C++, and then just broadcast the image through C++.
Yeah, it's certainly a better way to do it. So for now, just for development reasons.
What I was seeing online as well is that the problem with this camera is that the SDK was created for Windows. Apparently, someone got a hold of the code and then compiled it for Linux.
Yeah.
But it's for a version of Ubuntu. But what we want is for Orange. And so we either get the original code and we're able to compile for Orange, or otherwise we're always going to have these issues.
Yeah. Yeah. Yeah, true. Oh, where's my viewer? Here it is.
Hi, Richard, and
hey, Yanni.
everyone. Hey.
Oh damn, the cam bus. So this is the result, and it identifies in a kind of a bus error, which I think that the camera
Mhm.
blocks the USB bus, and the script, the Python side, can't send anything anymore to the bus, something like this. So I have to unplug it now and replug it. Yannick, I'm doing a little demo here on the ADSB integration, and I'm just caught in the act of the camera stalling due to buffer overflow. Okay, once again. Yeah, maybe even, Carlos, as you said, if we turn into the C++ code, turn it into a C++ code, then probably all this calibration stuff that I did here, maybe this is not of use anymore.
I think we're going to have the same issues because the library that we have is for Ubuntu. It's not for Orange. So even turning into C++ is still going to be an issue.
Okay, back to square one. So Yannick, just to repeat for you, this is the live view in our room here. You can see my hand, yeah, so that you see it live.
Yeah.
There's a little dot in the center. This is my dummy, so I can move it around, swing nicely, yeah. So now you see here a little needle hanging in the air on a little string that moves around, and the background shot. Thank you. This is also an issue I still have to solve, which is the timing between writing into the frame buffer and the exposure and gain changes. Meaning, if there are exposure and gain changes, I have to take care of this in the background subtractor, because every change in gain is a huge difference for the background subtractor, and that should be ignored at the time when the change happens. Let's see. Yeah, now it works. Okay, there's the little needle. Swing. Okay. And you see it catches it, the small
Okay,
needle.
now I see it, yeah.
It's only resolved as 4 pixels, but it's nicely captured by the background subtractor.
Yeah, that's really nice. Because I mean, it's not easy to see on the video.
So I undo it. So now it's without background subtractor. It's just the video. Close up, I zoomed in. Now here you see it's rather pixely, and the background subtractor captures it nicely. And the other stuff is the overlay of ADSB. So there are
Oh, I see.
ADSB.
I wasn't sure if I understood correctly, but this ADSB data.
Yeah.
Okay.
But it is live data.
Nice.
It's not from any server. I'm offline here, and I'm online. Otherwise, you wouldn't hear me. But I'm not picking up data from somewhere. This is
Nice.
an RTL SDR dongle on the Orange Pi 5 with an ADSB filtered antenna. So what you see here is live data from planes flying overhead. Although
Nice. That's great.
This is inside, so the camera is inside, but the antenna is next to the window. So yeah. Yeah, and it is.
That's great. I mean, I've worked on this 3 years ago or something, but this looks really nice.
Yeah, and it is live data, so it's local data.
Yeah. Mm-hmm.
Okay, so now nothing's flying overhead. So this is I'm using dump 1090, and it comes with a viewer. It runs as a service locally, and
this overlay is nice. It looks good.
this is just for work. This is not the final whatever. This is just what you see here. The view of the camera is around 160 degrees, not 180, because we can't come that close with the optic to the sensor to keep it sharp. So we have a trade-off of 10 degrees to the horizon. But anyways, Kristen is always complaining about the first 30 degrees above the horizon, and I'm fighting with him along this. But anyways, now it's 10 degrees above the horizon starting. So this is a circle of 160 degrees. This is a 90-degree circle, meaning if you stand right up as a human being and look 45 degrees into the sky, this is your circle.
Yeah.
Okay. And yeah, the position is projected onto the screen by this, just by azimuth and elevation. And I also introduced the orientation correction, because my camera is now pointing west. So there's a 90-degree orientation mismatch. So I reorient with variable, I just reorient the overlay.
Nice. Yeah. Great progress, I think.
This is just the tracker even works. Can I show you the tracker? Shall I? And this on the running record. Okay, let's give it a try. Yeah, let's do this. Okay, what the tracker is doing is picking up the same shared memories, and reading from the background subtracker shared memory and the metadata from the camera controller, and gives every blob, damn, go away, gives every blob that is here. So here are some blobs, okay? So some, I would say these are 20, 30 blobs around here. This is probably just one blob in the center. And yeah, there are maybe some 1, 2, 3 blobs. I still have to get rid of those blobs to eliminate them. But the tracker, where's my tracker now? Here. So this is the frame, and per frame we have several IIDs. So I just pick one frame, let's say the 34 frame. In frame 34 we had these IDs, these track IDs. Oh, it's not even that much. And I calculate the lifetime just to eliminate short ones that only have a very short lifetime. So this, with a lifetime 1, will only survive 212 if it is also seen in the next, 212 is seen in the next one. In the over next one, sorry, this is frame 34 and this is frame 37. So I'm still working on this on the tracker. I'm now skipping 3 frames just because of performance. I still have to optimize this towards having a real time. So this is in work, and yeah. And
nice. So you already have tracks.
yes, of course, but they're dirty tracks, because I would also track, let's say, what my movement here is. And that should not be in the track. So there's still morphology that has to go out. And this is Carlos' idea of the new tracking pipeline, which we built ourselves, where he wants to use 3 different background subtraction methods. The Gaussian mixed model, the vibe, and a third one is a distance, but maybe Carlos can be more explicit here. Carlos, can you help?
So the idea is to have so basically vibe and Gaussian mixture model, they complement each other on the background subtraction. But there's issues with the background subtraction, and so the idea is to have basically optical flow or difference from 3 frames or compensate for that. So an example is if we have a ghost, so it's an object that is part of the background and then moves out. So we need to integrate that over time. And those methods are better for that compared with background subtraction.
Mm-hmm.
It should be kind of a pipeline that has more things that work in parallel and a decision node that now decides which one is better at that particular moment for that frame. Or based on this, these frames, these 3 processes, for example, what is a track, what is an object that needs to be tracked and what not. I also wanted to show you, this is ArcTop, it shows the process performance. Now I'm also using OSB for recording this session, but OSB consumes 50% of all 8 cores. If I stop OSB, and I will show you later, but the recording will stop then, everything goes back to around 50-60%. And there's running the camera controller on 6 FPS with 3200 pixels in resolution, the background subtractor working in real time on the same material on half of the resolution. Now the viewer and the HDP projection, which is quite easy. What else is running? Yeah, the tracker was running, but the tracker dropouts were a different issue, not the process consume issues.
Mm-hmm.
So
I'm just a little bit distracted by the ADSB data because there's the altitude set feet instead of meter.
Oh, that's a good one. Thank you very much for pointing this out.
Yeah, I think it should be feet, right?
This is certainly feet. Yes, you're right.
Yeah. Yeah.
But the distance too is.
And the distance. Yeah, the distance too, right? Yeah. Yeah.
So I can do it here. Where's Altbaro? Yes, 34,000. They always give it in feet here. That's the direct dump from the RTL driver. And this is the very same as here. So yes, it is in feet, and I have to correct this. Altitude in feet. But the distance is calculated.
Maybe you can put a space before that, then maybe that's.
You mean a space between the cipher and the
Yeah. Then you have a space between the number and the unit. It's just my how you call it, OCD. So
just the space here.
Yeah.
There's none. There's one. This one, the distance is in meters.
The distance is also feet, right?
No, but
no,
you're right. Because the input.
but maybe you can also we could maybe calculate that into meter because it's doesn't have to be now, but it's feed is only really informative for the US users, right? So
yes, you're right. Yeah. Feet.
Yeah,
Okay.
nice.
Yeah. So that's my current work here. So I still have to do the adjustment between the auto exposure, giving off exposure and gain, and taking this over into the background subtractor. So not the background subtractor, updating the history when exposure or gain are changing. And the second is to make the camera controller more in sync. And yes, Carlos, we should go into C++, definitely, with all of it.
Hmm?
But this is just Python here. So just for hacking out, Python is great. And then turning this into C++ should be a snatch, wouldn't it? This is an interesting one because this one is
I
about
was thinking the other way around is if we find an implementation in C++, then we could, if we could use it, that would be better.
So you mean that we have a start with a structure that is already in C++? Yeah, because we have certainly differences in the code. Because, for example, we use a ring buffer. They don't. And we need the ring buffer, as you know. So yes, we can.
Yeah, my question is more on the SDK because the SDK comes from Windows implementation,
Yeah.
and someone compiled it to Linux Ubuntu. But now we need to compile it for Orange. Otherwise, we're always going to have these issues with with the drivers.
So you say we have to recompile the SDK, but we don't have the code, the source.
Ideally, that's what would be.
So in this case, we would need to recompile the SDK, wouldn't we?
Yeah.
Do we have the access to the source code?
Not find it online, so it seems to be just compiled. Yeah, that's an issue. And so we're always going to be fighting with these problems. It's always going to be crashing and things like that.
Yeah, okay, but at least the SDK is the SDK not. So the SDK that we are using here is the very same SDK that we can use with C++, right?
Yes, yeah, it's but this is for Linux Ubuntu, so it's not compiled for Orange.
Yeah, true. But in the case we cannot
I
compile
mean,
it because we.
so if you had a yeah,
I'm just saying in case we.
if you connect the camera to your PC and you have either Windows or Ubuntu in it, you probably don't run into these issues, these crashes as often.
Yes, probably, but actually, Carlos, that doesn't help because we have to make it run on the Orange Pi 5 and not on a Windows computer.
Yes.
And that's the topic, the issue. So if we.
Yeah, so unless we are able to compile the SDK, we're always going to have these issues. There's not much we can do.
Okay, so I think most of the issue comes from timing with the camera because the SDK does not give information about the status of the camera. So I don't know when it's ready to receive another command, for example. The only thing I did in the calibration is, and this is not from me, it's from forum users that also use QHY cameras, and they do a procedure of starting with fetching single frames because this forces the camera into a certain sync. And somehow it works because if I do not do this fetching single frames before, the live frame won't succeed. So this is odd, yeah? But I have to do this 3 times, fetching single frames, and then the next step, starting live frame, will work. But the the real issue, I think, at the moment is to not overload the camera with requests. And I'm doing this because I have a bad timing, and to keep the target FPS. So it's not working as it should be. And I think from this comes the overload on requests towards the camera, and at a certain level, it just stops. And I don't think, I mean, if we could patch the source code, if we had it, we could help. But if we don't have the source code, we can just walk around and walk around the problem. No?
The problem is, as it happened right now, is that it might crash, and you're forced to go there physically and just plug out the USB and plug in again.
Yeah, sure. That's why my first step is, my next step is to fix this, so that it really runs on 6 frames per second, because I'm 100% sure that this will certainly not overload the camera. So this should actually eliminate the USB overload. And I'm using the camera with USB speed 0, which is, according to documentation, a kind of an auto mode. So, because when there are tools where you can watch the USB traffic, it changes speed. So the driver has to do something with the USB speed. Yeah, so I would say, Carlos, if you find the code, that would be great. Then we could compile it ourselves. Absolutely, I'm totally with you. As long as we do not have the source code, we have to work with that, what we have. Yeah. Yeah, okay, so actually that was it, my demo. I stop recording now.